Next example, example number 4. Find inverse Laplace of 1 upon s plus 1 and s square plus 1 by convolution theorem. Okay. Therefore, once again a product of two terms, 1 upon s plus 1 and 1 upon s square plus 1, whose inverse is known. Therefore, solution, let we have inverse of 1 upon s plus 1 as standard result e raised to minus 80, a is there 1, therefore e raised to minus t. And the second inverse inverse Laplace of second term 1 upon s square plus 1 as 1 by a sin 80, therefore here a is 1, therefore 1 by 1, and sin 80 a is 1, therefore sin t. Here one term of t and again one term of t, therefore any one of f of t and second one as g of t. I will consider this as f of t and this as g of t, or we can interchange. Final answer we get the same, and therefore by convolution theorem we get inverse Laplace of 1 upon s plus 1 into 1 upon s square plus 1 as integral from 0 to t f of u into g of t minus u. Okay, and therefore it is equals to integral from 0 to t f of u. Replace t by u, we get e raised to minus u, and here replace t by t minus u, we get sine of t minus u du. And to obtain this, we take the help of the standard result. We know that integration of e raised to ax sine of bx dx, or bx plus c we can consider, as the result as e raised to ax upon a square plus b square a sin bx minus b cos of bx. Okay, using this standard result. Therefore, to apply this, we have to compare and get the values of a and b. Here we get a as e raised to x, coefficient of u minus 1, and b as again minus 1, c as t, and x means u. Okay, therefore comparing and obtaining these values, and then performing this by this result, e raised to x, instead of that we have here e raised to minus u divided by a square plus b square. A is minus 1 square is 1, b square again minus 1 square 1, a sin bx, a is minus 1, sine of bx plus c. Here I can rewrite it. It is e raised to ax upon a square plus b square a sine of bx plus c minus b cos of bx plus c. This is that result. Okay, and therefore it is sine of bx plus c means sine of t minus u. Minus b is minus 1 and this minus it becomes plus 1 cos of bx plus c cos of t minus u, and the limit for this complete bracket, outer bracket, and therefore the limits from 0 to t. Okay. And therefore substituting the upper limit for us t here, therefore it becomes e raised to minus t upon 1 plus 1 2 multiplied by here it is t minus t sine 0 is 0 plus t minus t cos 0 is 1. Therefore for upper limit we have this one minus lower limit for u as 0 e raised to 0 1 by 2. Substitute the value of u as 0 here, we get minus sine t. Okay, and u as 0 here we get cos t. And from these two terms I can take 1 by 2 common. The remaining terms are e raised to minus t first, this minus plus sin t, and this is minus cos t as the required inverse Laplace by convolution technique as the required. Okay, therefore for this type of example means when we have a product of e raised to x sin bx plus c or e raised to x cos of bx plus c, we have to apply that standard results for integration. Last example number 5th. Find inverse Laplace of s upon s square plus 4 s square plus 4 into 1 upon s square plus 1. Okay, by convolution. Again here a product of two terms of s, therefore we have to apply convolution theorem. We have let inverse Laplace of first term s upon s square plus 2 square 4 means, and as per the standard result it is cos of at, cos of a is here 2, therefore 2t, and the second inverse of 1 upon s square plus 1 is again standard result 1 by a 1 by 1 sine of a t sine of t. Therefore, one has f of t, second has g of t. I will consider this as f of t and this as g of t. Or we can interchange it, no problem. Therefore, by convolution theorem, we get inverse Laplace of 1 upon s square plus 1 into s upon as integral from 0 to t f of u g of t minus u, and therefore it is equals to integral from 0 to t f of u, replacing t by u here, we get cos of 2u, okay, and replacing t by t minus u here, we get sine of t minus u du, okay. Product of two terms of sine and cosine, therefore applying that standard result, but for that first of all we have to multiply it by 2 and divide by 2, and so that we can apply that standard result. Therefore it is 1 by 2 integral from 0 to t 2 times sine of t minus u and cos of 2u du. Yes, what standard result we can apply here? We know that 2 sine a cos b is equals to sine a plus b plus sine of a minus b. 2 sine a cos b as sine a plus b plus sine of a minus b. Okay, and therefore applying that, it is 1 by 2 integral from 0 to t 2 sine a cos b. This one has a capital and this one has b. Therefore a plus b, addition of this, therefore it is sine of t minus u plus 2u plus sine of a minus b, a is t minus u minus 2u, and then its integration with respect to u, and therefore it is 1 by 2 integral from 0 to t, simplifying it, it is sine of 2u minus u, we get sine of t plus u, and sine of t minus u minus 2u, we get 3u. Okay, integrating this with respect to u, therefore it is equals to 1 by 2 as it is. Integration of sine is minus cos of t plus u divided by the coefficient of u 1. Therefore, it remains same. Integration of the second term, sine is again minus cos of t minus 3u divided by coefficient of u minus 3, and the limits from 0 to t. Okay, and therefore 1 by 2, rewrite it, this minus minus will become plus, it is cos of t minus 3u and minus and divided by 3 and minus cos of t plus u, limits from 0 to t. And therefore, substituting the upper and lower limit, upper limit for u as t, when we put here, it becomes 1 by 3 cos of t minus 3t. T minus 3t is minus 2t. I will directly substitute the upper and lower for this term, and when lower limit is 0 here, it is cos t. I have substituted upper and lower limit for the first term, then minus upper minus lower. For upper it is t, therefore cos of t plus t, we get 2t, minus a lower limit at 0 here, we get cos t. And rewrite it, it is 1 by 2, cos minus theta is cos theta, therefore it is 1 by 3 cos of 2t minus 1 by 3 cos t minus cos of 2t minus plus cos t. Okay, there are two terms of cos t, we can combine it, and two terms of cos 2t, we can combine it. Therefore 1 by 2, when we take cos 2t common, here it is 1 by 3 minus 1 into cos of 2t, and when we combine it, it is 1 minus 1 by 3 times cos t, adding the same term. Therefore it is 1 by 2, 1 minus 3, we get 1 minus 3 means minus 2 by 3 cos of 2t, and 3 minus 1, we get 2 by 3 cos t. From this two term I can take 2 by 3 common, therefore 1 by 2 into 2 by 3, here it is cos t, positive term I will write on first, and minus cos of 2t, 2 to get cancelled. Therefore final answer is 1 by 3 cos t minus cos 2t as the required answer. Okay. Therefore, with the help of all this 5 example, I have explained how we can apply convolution theorem to find the inverse Laplace transform when there is a product of two terms of s, a function of s. If you are watching my videos, please like and share it, as well as subscribe to my channel for latest updates. Thank you.